Yes. Good afternoon, dear. Tell me first, audio and video both are clear to all of you? Yes, please tell me, dear. Sir, आप ISC Bangalore से हैं? Yes, my dear friend, I am from ISC Bangalore. I have done MTech in 2010. Yes. Good afternoon, dear. Good afternoon. Yes, dear. Tell me, audio, video both are clear to all of you? Okay. I think from my side, all the points are clear. Okay? Yes, tell me, dear, fast. Everyone. Okay? So your energy level, you are really serious to learn lot of concept related to Ohm's law. My dear friend, today we are going to discuss like most important and versatile things about the Ohm's law. Okay, in which type of circuit, or in our example when some information is given, so for which type of information we can directly apply Ohm's law, we are going to learn. Okay, yes, very nice. Yes, very nice, dear. So Ohm's law application. First thing, within 10 to 15 minutes, I will explain how we can use Ohm's law only for conductor, and tomorrow we will discuss for inductor and capacitor also. Okay. So my dear friend, first I want to ask you a very simple question. Let us assume we have some dynamic resistance. Okay, dynamic resistance. Please mind it. Dynamic resistance, first thing. And second, I want to say distributed element. Okay, any element, distributed element. Okay, for all or for these two types of conductors, our Ohm's law is valid or not? Please tell me fast, dear. For the dynamic resistance and distributed elements, for example, you know, two types elements, we have lambda parameters and distributed parameters. So for distributed parameters and dynamic resistance, our Ohm's law is valid or not? Please tell me fast. Our Ohm's law is valid. Sir, please tell what is the active and passive network. I can't find its exact definition. Okay, so definitely, dear, I will explain. Okay, so this time we will crack 22. Yeah, definitely, Balak, definitely. We are doing same. We are doing this job for the your like achievement ki. You can score good marks, you can score good rank, and you can make your career with the help of me and Gate Academy platform. Okay, yeah, very nice. So my dear friend, first thing, for dynamic resistance and for distributed elements, Ohm's law is valid only for a particular instant, not for entire length or for entire circuit. Okay, if you will study power system or communication system, like from EC background or from electrical background, in those type of examples you can easily identify, okay, we can apply Ohm's law only for particular section, not for entire length or entire circuit. Yeah, very nice. Now I want to ask you, beta, if we have simple one resistance in this fashion, okay, we have some conductor, and I want to say one current is flowing in this fashion, I, then what will be the voltage like polarity? Will be this yellow one, or my dear friend, will be this one? Okay, you may think, sir, asking very silly or stupid question, but I need actually at this moment this response also. Suppose I want to say, beta, in resistive element, current is flowing from terminal A to B, then what will be the generation of polarity of voltage? Like white one or yellow one? Can you tell me? Yes, actually I need answer from your side, only then we can continue this session. Okay, because without your response, you know, feeling not good. So this is the thing, my dear friend, in the resistance, current always flow higher to lower potential. It is really very easy things, but I want to tell you. So first thing, in conductor, wording, please mind the wording. I'm not talking about semiconductor. I'm not talking about inductor or capacitor. I'm talking about simple conductor. So in conductor, current always flow. See my wording, current always flow from higher to lower potential. From higher to lower potential. Okay, from higher to lower potential. This is the most important statement here. Now I want to ask you again, very easy question. let us assume I want to say beta, first we have some inductor in this fashion, and I want to say this is the terminal A and B, and want to say, let us assume the direction of I is this one. Then what will be the voltage polarity generated across inductor? Minus plus or plus minus, first one or second one? Can you tell me? If we have one inductor, then what can be the polarity if the direction of current is fixed? If the direction of current is fixed, so what will be the inductor voltage polarity? Either first one or second one. Please, everyone. So this is are the basic to pull down the entire network theory. Yeah, that is the main. So that's why I want to discuss with all the points related to Ohm's law, so that we can easily handle circuit related to. Okay. Yeah, very nice. So first one. Now think over it, my dear friend. Here in inductor, current is flowing already from terminal A to B. Now I want to ask you very simple question. What will be the generated polarity across this inductor, either first one or second one? Okay. Yeah, I'm waiting for your response. Both possible. Very nice. So everyone beta, please follow Vishwakarma. He is absolutely correct. Here in inductor, please mind it, in inductor beta, both polarities are possible. Why, my dear friend? Because the resistive element can only dissipate energy. So it is responsible only to consume power or energy. Whereas our inductor and capacitor can absorb as well as deliver for a very short time period. For a very short time period, it is the most important statement at this moment. Okay. So now see, when this inductor is going to absorb power or energy, first polarity will be correct, and when it is going to deliver energy or power, second polarity will be correct. Same thing we can apply for capacitor. First tell me, till now all the points are clear? Please everyone tell me, all the points are clear beta? So what is the conclusion? Conclusion is this. Let us assume, my dear friend, we have one unknown element X. Doesn't matter this element X is an active element or passive element. Okay, anything. So I want to write in short, this is active or passive, doesn't matter, my dear friend. Here, if the current is flowing from higher to lower potential in this fashion, okay, in this fashion, then this element will absorb power. Doesn't matter. It is the active element or passive element, resistor, inductor, capacitor, voltage source, current source, AC, DC, independent, dependent, anything. If the current is flowing from higher to lower potential, guaranteed our element is going to absorb power. Please tell me everyone, it is clear or not? Next thing I want to tell you, my dear friend. Okay. See here, this point is clear, I think. Now I want to tell you, again, if we have some X element in this fashion, and this element can be active or passive. If the current is flowing, from lower to higher potential in this fashion, doesn't matter any element, then definitely power will deliver. So see, these two statements are really very, very important. When current flows higher to lower, power will absorb, doesn't matter which type element is present, active or passive, independent or dependent. Similarly here, my dear friend, when any active or passive element is present, if the current is flowing negative to positive, definitely this element is going to deliver power. And obviously in this situation, resistance cannot be the part. Okay. So resistance cannot deliver energy. Hopefully all the points are clear. Yes, very nice, very nice. Now again, my dear friend, I want to ask you a very stupid question, but it is really basic. So I want to cover all the points related to basics. Can you tell me beta, what is Ohm's law? Okay, I'm not going in detail, okay, because DC sir already discussed a lot of things about the Ohm's law. Okay, so I just want to discuss very or few things, or we can say important things, whatever we require to handle our network, or in analog or in power system, power electronics, anywhere, okay, wherever it is applicable. So Ohm's law, okay. So I want to ask you, The first form of Ohm's law is nothing but J is equal to sigma E. Okay, maybe you have studied this equation in the physics. Okay, now after modification of this equation, we can write, my dear friend, I proportional to V. Okay, now my dear friend, the most important thing, this equation is again Ohm's law and valid only for conductors, and valid only for conductors. This is the first thing. Is valid only for conductors is the first thing. Okay, please be serious, because in the GATE examination as well as in the ESE examination or in any other PSUs or any other state level exam, you will get such type of question everywhere. So please don't ignore anything. Okay, whatever you are learning at this moment, I proportional to V is valid only for conductors. Another thing, my dear friend, okay, whenever we want to expand this equation, we can write V is equal to IR again. Okay, try to understand each point. Where, please mind it beta, where this element R is constant, okay, we are not considering any temperature variation somewhere here. So this V is nothing but the potential difference across R. The potential difference across R. My dear friend, this V cannot be independent quantity. I repeat, my dear friend, this V cannot be independent quantity. Independent quantity. Okay, I'm not focusing on spelling. Independent quantity. It means this V cannot be AC independent, cannot be DC independent. Okay. So in other words, we can say the V and I cannot be active element. I repeat, this V and I cannot be active element. Hopefully you are getting all the points whatever I want to tell you at this moment. So V and I again cannot be active element. Okay, cannot be active element. That means this V cannot be the voltage of any DC battery. This I cannot be the current of any current source. Doesn't matter you are considering DC current source or DC voltage source or AC voltage source or AC current source. In other words, my dear friend, this voltage is nothing but the developed electric field across this resistance. Hopefully all the points are clear. Please tell me, everyone, you are learning or not? Please tell me fast, dear. You are learning or not? I'm not increasing my speed, my dear friend, because out of you, some student maybe are beginner, okay, so they can understand all the points very clearly, and after some time you realize that what is the actually importance of Ohm's law. Okay, please tell me, everyone. Yes. Okay, so hopefully you are getting, and meanwhile please give me response also, okay, whether you are learning or not. So now I want to ask you very easy example to all of you, very easy examples. Okay, let us assume, my dear friend, we have one example in this fashion. Okay, the example is we have one circuit, and this circuit is connected with some mechanical switch, and I want to introduce two resistance somewhere here. And this example I have discussed many times with my students, and trust me, I have never received any correct answer from anyone in my entire 10 years experience. So again, this example is coming in front of you. Okay, so this is the online platform, so maybe out of you some students are familiar with this example, but still I want to discuss, okay, because this example will like tell you lot of concept regarding Ohm's law. Okay, so I want to ask you very easy question, beta. Let us assume some current I is here. Okay, so this is the Vs, which is independent voltage source or battery. So I want to replace by battery so that no controversy should be there. So this is some independent voltage source Vs, and here this switch is there. That switch is going to close at equal to 0. The current I, and we have two like static resistance R1 and R2, and the potential difference across R1 and R2 is V1 and V2. Okay, something. So according to Ohm's law, I want to ask, according to Ohm's law, okay, which of the following statements are correct? Okay, first tell me, dear, the question is clear. Which of the following statements are correct? First option, first statement I want to give you, my dear friend. After closing the switch, or you can say after closing the switch. So I'm writing after closing the switch. After closing the switch. So after closing the switch, how many statements are correct? You have to tell me. So first statement, I want to write I proportional to V1. Second statement, I proportional to V2. Third statement, I proportional to Vs. Fourth statement, my dear friend, I proportional to R1 plus R2. Okay, R1 plus R2. Fifth statement, let me change this color. Fifth statement is Vs proportional to V1 plus V2. And sixth statement is Vs is equal to I into R1 plus I into R2. Okay. And seventh statement is this one, V1, and yeah, done. So V1 plus V2 is equal to Vs. Okay, so now you have almost seven equations. Okay, so first, second, third, fourth, and fifth, sixth, seven. So out of all these equations, how many equations are going to satisfy Ohm's law? Okay, this thing you have to tell. Your time starts now. Yes, think over it, my dear friend, and tell me. Okay, V and I cannot be active. Yeah, very nice. V and I cannot be active. Yes, think over it properly. Okay, I'm not coming in front of board, so you can read the question properly. According to Ohm's law, which of the following statements are correct after closing the switch? Okay, simple circuit, you can observe some Vs is there, I, R1, R2, the potential difference across R1 and R2 are V1 and V2 respectively. So here your first equation is I proportional to V1, I proportional to V2, third is I proportional to Vs, fourth one is I proportional to R1 plus R2, then Vs proportional to V1 plus V2, Vs equal to I R1 plus I R2 something, and V1 plus V2 is equal to Vs. Okay, yeah, very nice, my dear friend. So here fourth and third, fourth and sixth something. Okay, sixth. No, my dear friend, what you have to do at this moment, please. How we can handle the question? See, it is the beginning. We have a lot of time either for ESE exam or for upcoming GATE examination. Okay, what I'm telling, but see, we have sufficient time, my dear friend. So at this moment, please don't get panic and try to understand the concepts. Okay, whatever you have studied from the DC sir or today with me, all the concept and properties related to Ohm's law you have to apply simultaneously in the circuit. Okay, what is Ohm's law, where we can apply, what are the restrictions of Ohm's law, okay, how we can identify whether Ohm's law is applicable or not. Okay, we have already discussed a lot of things. So please try to understand the concept first, then apply all the concept, okay, related to your question, and then try to identify whether you are going in correct direction or not. Okay, after that finalize your answer. Okay, yes, again you have some time, around 1 minute. Okay, so I'm waiting for your response. Okay, I'm asking very easy question, beta. According to Ohm's law, which of the following statements are correct? Okay, which of the following statements are correct? So first, second, sixth and seventh. Okay, I got it. Sixth, Akash saying it is 3. No, my dear friend, still I'm not getting correct answer. So think over it. Yes, think over it. Yeah, Shivam saying it is 6. Shivam, I think again, no, how many equations are going to satisfy Ohm's law? Very easy question. 1, 6 and 7, 3, 6 and 7. Okay, Ramkrishnan. Still, I think it is not correct. My dear friend, simple, yaar, conductor. What is Ohm's law? I proportional to B. Okay, just rectify how many number of equations are going to satisfy I proportional to B relationship. Those equations will be correct answer. Those equations will be correct answer. Okay, and meanwhile, please do like and share this session with your friends so everyone can get benefited. Okay. Yeah, third one, Neeraj is still not correct. Okay, no issue. But trust me, I'm not telling to you any answer regarding this question, but I will discuss again the theory related to Ohm's law. So just wait. Okay, here, I want to tell you a few things. See, let us assume, my dear friend, here we have some resistive element in this fashion, and I want to say, beta, please mind it, some I is there, and here some voltage V1. So according to Ohm's law, can we write here I proportional to V1 is correct or not? Please tell me, everyone. Is correct or not? Yes. Show your energy level, my dear friend. Okay, I need responses from everyone. I proportional to V1 is correct or not? Yes, my dear friend. Yes, sir. Why? Because this is conductor. Okay, nothing is given related to this R, like whether the R value is infinite or 0. Okay, such type of information are not given. It is simple conductor, so we can write I proportional to V, definitely. Okay, now what I want to tell you, my dear friend, let us assume again we have some resistance R2, and I want to say some current I is, or same current I is flowing, and here some V2 is there. Again, can we define Ohm's law for the same? Yes, my dear friend. Yes, sir. We can define I proportional to V2. Okay. Next thing I want to tell you, my dear friend, let us assume some current source is here, and the voltage is this V. Okay, or I want to write some Vs, and the current amount of this current source is Is. Now I want to ask you very easy question. Okay, listen to me carefully, my dear friend. I want to ask you very silly question or very easy question. This Is is, if it is DC current source, this Is is independent quantity or dependent quantity? Everyone please tell me. This Is is independent quantity or dependent? I need answer, beta. Yes, please tell me fast. This Is will be independent quantity or dependent quantity if this is DC independent current source. If this is DC independent current source. And same in the same way, please tell me, this Vs will be independent or dependent quantity. First tell me about Is, then very nice, my dear friend. So this Is is independent quantity. See the magic of the Ohm's law, independent quantity. Hopefully this thing is clear. What about this Vs, my dear friend? Can you tell me? The voltage across current source. Will be independent or dependent? Think over it and tell me. Everyone, boss. Yeah, very nice. So this Vs, my dear friend, will be dependent quantity. How? Some students are thinking like this. My dear friend, it is really very easy. Why this Vs is dependent quantity? Because the circuit in which this current source is present, that circuit is going to tell you what will be the amount of Vs. That Vs may be 0, maybe some non-zero value, maybe positive, maybe negative. Now, I want to say, yes sir, I totally agree. The Is is independent quantity, Vs is dependent quantity. But sir, I have some doubt. According to Ohm's law, if I want to write some equation, Is proportional to Vs will be correct or not, my dear friend? Will be correct or not? This is the current Is. I want to write somewhere here. This is the voltage Vs I want to write here. So can you tell me, my dear friend, this equation according to Ohm's law will be correct or not? Everyone. Okay, everyone, my dear friend, I need answer. Yeah, think over it. According to Ohm's law, this Is proportional to Vs will be correct or not? Okay, see, in the GATE examination as well as in the ESE subjective or prelims examination, sometimes really we require good quality of content. Why, my dear friend? because you know very well this competition, okay, this word, competition word, okay, you are not supposed to ignore. Okay, we can understand easily almost more than 25 or 30,000 students will sit in the examination of ESE prelims, and hardly qualified student will be not more than 500 or 600, and then you have to write mains examination. Okay, so think properly. It can be any criteria, maybe more than 1,000, but yeah, you have to come in the best student list. Okay, so that's why I want to discuss each and everything related to our Ohm's law. Yeah, very nice. So my dear friend, I am very serious at this moment, and I want to say this equation is not valid according to Ohm's law. Okay, Ohm's law never said such type of equations. Okay, Ohm's law never given any equation related to independent element. Ohm's law always said, my dear friend, whatever current will flow through the resistance, that current will generate some potential difference. Okay, and then that potential difference will always proportional to current. This thing is said by the Ohm's law for conductors. What about for inductor and capacitor, and for rest element I am not discussing at this moment. But Ohm's law didn't completed his job only after achieving this rule I proportional to V. Okay, he has been covered or discovered lot of formulas related to different type of material in different field. Okay, we are not going to discuss all those things. Today, I want to discuss only DC circuit with the help of resistive element. Okay, I don't want to introduce any inductor, capacitor or many more elements. Hopefully, all the points are clear to all of you. So here I want to say, my dear friend, this obviously IES is not proportional to VS. Why? Because here this IES is independent. Let us assume, my dear friend, we have one circuit at this moment, and this IS value is 10 ampere, and here I want to say some resistance, which resistance is variable one. Okay, variable one, and I want to write here some voltage. That voltage is Vs. Can you tell me, my dear friend, if the value of this R, okay, if the value of this R, Vs and Is, so can you tell me, my dear friend, when the value of R is 0 ohm, what will be the current value Is? You will say, sir, what is this question? Is definitely independent amount, so it will be always 10 ampere only. But sir, when this resistance is 0 ohm, whatever current will flow in this fashion, the voltage generated here by Ohm's law will be 0. Okay, so this is the 0 volt. Next thing, let us assume, betaji, I want to say this R is 1 ohm. R is 1 ohm. Now, what will be the voltage developed across this? It is nothing but beta 10 into 1. So here voltage developed 10 volt, and this current is still 10 ampere. Next thing I want to tell you, let us assume this R is 10 ohm. Okay, this R is 10 ohm. So if this R is 10 ohm, then again voltage developed 10 into 10, 100. So when this is 10 ohm, this will be 100 volt, and this is 10. See, for any value of for any variable value of voltage, our current is constant, and this thing not valid according to Ohm's law. So that's why the conclusion is, for all independent and dependent, see my wording, for all independent and dependent active element, doesn't matter those elements are DC or AC, our Ohm's law is never applicable. Hopefully these statements are clear. Okay, yes, now tell me, dear everyone, all the points are clear? Very nice. Okay, now see, now we have got lot of things related to Ohm's law. I want to ask you very easy question again, beta, or I want to ask you same question again, beta. Can you tell me now how many number of statements can be correct according to Ohm's law? Yeah, it is really easy at this moment after discussion of previous theory. Yeah, think over it. How many statements can be correct according to Ohm's law? Yeah. Yes, everyone, think over it and tell me how many number of statements can be correct at this moment. See, according to Ohm's law, this is the circuit. Now, can you tell me, dear, this Vs will be independent or dependent? Yes, sir, we know it. It is independent. So, for independent, Ohm's law not valid. Now, my dear friend, I want to tell you, the Vs is independent. See properly, Vs is independent. So the equations, whatever contain this Vs, beta, the equations, okay, whatever contain this Vs are, okay, something happened, just give me, yeah. So this Vs beta independent, 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 and independent can never be proportional to any dependent. See, it's very easy. Independent can never be proportional to any dependent. Any dependent. So that means according to Ohm's law, at least beta fifth one incorrect, sixth one incorrect, seventh one incorrect. Please tell me these points are clear to everyone? Yes. Yes, speak up, tell me. These points are clear to everyone? Yes. Hopefully. Yeah, please reply fast. Reply fast. Yes, very nice, very nice. Now see, next thing, my dear friend. See beta, this current I is there. See, very easy now. This current I is there, okay? Now beta, some R1 is there. When this I will multiply with this, V1 will develop. So this V1 is not independent quantity. This V1 is not independent. This V2 is not independent. V1 is nothing but I into R1, V2 is nothing but I into R2. So definitely I proportional to V1 and I proportional to V2. So according to Ohm's law, my dear friend, first is correct, second is correct. What about third one beta? This is dependent, this is independent. Obviously not possible. Obviously not possible. And now here I proportional to R1, R2. What is this? What is this? I proportional to R1, R2? Obviously not correct. Okay, such type of result we can never write beta. This current is proportional to some constant. Okay, see, my dear friend, this is the constant sum, na? R or something. So obviously this is not correct relationship. So only correct relationships are first and second. Only correct relationships are first and second according to Ohm's law. So the student whoever replied correct this first and second, correct statements are first and second, then definitely those students are absolutely correct. Yes, so sir, VI can be correct as per, yeah, definitely Vishwakarma, VI, this equation, this equation, Vs is equal to I R1 R2 or I R1 plus I R2 something is correct according to KVL. Is correct according to KVL. Okay, so hopefully this thing is clear. So now only first and second statement are clear. Now at this moment I think you are much comfortable, okay, like related to Ohm's law, where it is applicable or in which type of elements it is not applicable. Yes, please tell me, raise your hand and show your energy level, whether you are now you are capable to identify, okay, in the elements, okay, when we can apply Ohm's law or when we cannot apply Ohm's law. Please tell me fast. Okay. Yes, everyone. Yes, everyone tell me. Everyone tell me. Yeah, very nice, very nice, very nice, dear. Now I want to again discuss few things. Okay, where we can apply Ohm's law directly in our circuit. My question is really very important at this moment. Where we can apply directly Ohm's law in our circuit, or we can handle our circuit mainly with the help of Ohm's law. Definitely there will be some role of KCL and KVL will be, but mainly we are not going to deal our circuit with the help of KCL and KVL. We want to apply Ohm's law. Why? Because Ohm's law mathematical analysis is really very easy. Okay, so the moment at which we are going to apply Ohm's law, we can give the surety or a surety, okay, that we are going to handle this question in minimum time in comparison to any other person, okay, whoever going to handle same circuit either by a KCL, KVL, super mesh, super node or any other method, okay, because the Ohm's law content like mathematical way is very less, so we can easily handle even without calculator, okay. So hopefully these points are clear. So now question is, when we can apply directly Ohm's law, sorry, when we can apply directly Ohm's law in our Ohm's law, in our given circuit, hopefully this statement is clear to everyone. Now question arises, sir, how we can identify, yeah, thank you DC sir. Okay, so yeah, so we when we can apply beta directly Ohm's law in our given circuit. So my question is there beta, let us assume I have some question in this fashion. Okay, so sorry, I have one circuit in this fashion beta, some R there. Okay, and here we have some voltage in this way. Okay, this is some Vs. Okay, try to understand. Vs is there, obviously independent quantity, and I want to say this is 2 ohm, this is 4 ohm, this is 6 ohm. Can you tell me directly the value of current through this resistance? The value of current through this resistance, I. Can you tell me, everyone? Can you tell me, dear? Can you tell me, dear? The value of I. Okay, so you will say, sir, it is really very easy. We can apply KVL or KCL. Okay, so it will be better. Just try to identify beta what will be the potential difference across this resistance. I repeat, what is the potential difference across this resistance? If the potential difference is known and the value of resistance is known, easily we can calculate current I. Okay, don't take this example is easy or hard. Okay, try to understand the concept of whatever I want to tell you. Okay, so now my dear friend, here let us assume some ground is there, and with respect to ground, how much voltage will reach here? That is nothing but Vs. So this current I is nothing but potential difference. This current I is nothing but the potential difference, and this potential difference is nothing but Vs. I am considering this Vs as a positive value. Okay, so now this current will flow from high to low potential. Okay, so what will be the current I? I is nothing but Vs by R ampere. Hopefully this statement is clear. Now what is the conclusion? Very nice, my dear friend. Conclusion is this. Here, please mind it beta, whatever I want to tell you, please mind it. Here we cannot apply Ohm's law. Ohm's law not valid, but somewhere here we can apply Ohm's law. Now I want to change again this circuit configuration. Let us assume, my dear friend, here we have some resistance, another resistance R1, and I want to ask you what will be the current through this resistance. Okay, now we cannot directly tell just by Ohm's law. See properly. Now beta, this current I we want to identify. Okay, but now directly no potential difference we can easily identify. So first I want to remove this Vs. Try to understand the phenomena concept. Here some drop will be there. Here beta, some unknown parameter are there. We don't know anything about the current or voltage across any element. So now we cannot handle this circuit directly by Ohm's law. Bit confused, sir, not seriously, not cleared. Okay, see whatever information we have discussed, I want to repeat. Simple statement. If our given circuit does not have any voltage or current information, simple statement. If our given circuit does not have any information related to current or voltage of any passive element, resistor, inductor or capacitor, we can't apply Ohm's law directly. But my dear friend, if in the given circuit single passive element will have some information related to current or voltage for itself, directly we can apply Ohm's law. For example, here we cannot apply Ohm's law because the resistance, this 4 ohm, 6 ohm, 2 ohm or this R1, current and voltage are not directly given. But let us assume, I want to say, my dear friend, somewhere here 6 ampere current is flowing. Now I want to ask you what will be the current through this resistance we can handle by Ohm's law. How? I want to tell you. See here. Now my dear friend, the direction of current is given. We know it. Now 6 into 6 according to Ohm's law. How much voltage will develop? It is easy now. How much voltage will develop beta? According to Ohm's law, See here, 6 into 6 is 36 volt and 6 into 4 beta plus minus 24 volts. As I told you in the beginning of this session, in the resistance, current always flow higher to lower potential. So with respect to ground, how much voltage will reach here beta? How much voltage will reach here is 36 plus 24 is nothing but I think 60. Okay. So yeah, 60 volts. So now we want to identify this current I just by Ohm's law. 60 by 2 is nothing but 30 ampere. We don't require any KCL or KVL. Now tell me my dear friend, you are getting my points or not? Okay, yes, everyone. See, when current of any resistance given or voltage of any resistance given, we can directly handle our circuit by Ohm's law, or at least we can start the circuit analysis by Ohm's law. Okay, now tell me, these points are clear or not? Yes, everyone, yeah. Everyone, tell me, dear. Okay, very nice, very nice. Are you enjoying this session or not? Please tell me truth. Are you enjoying this session or not? So what is the conclusion? The conclusion is this, my dear friend. When voltage or current of any resistance is given in the circuit, directly we can apply Ohm's law to handle our circuit in spite of KCL or KVL. If you require, you can apply, but at least you have to start by Ohm's law. If this information is given, the voltage and current of resistive element are technically पढ़ने में मजा आता है sir. Yeah, thank you. Enjoying and our small doubts in network getting clear session is thank you dear Suryateja. Okay, yes, everyone tell me dear. Okay, very nice. Now my dear friend, we are going to discuss few examples. Okay, and after discussing all those examples, I assure you that you will feel comfortable with Ohm's law. Okay, so give me few seconds to get that example. Okay, I have already taken some examples. Just give me a few seconds. Yeah, this is our example, first example, and you have to apply like KCL, KVL or any other method, whatever you know, okay, but at least follow me whatever we have discussed in the 2D lecture, okay. So this is your first example. Calculate the power delivered by the current source I. Calculate the power delivered by the current source I. Start your job. Calculate the power delivered by the current source I. Okay, so just I want to shift this example somewhere here. Okay, and now we will see the magic of Ohm's law, how we can handle our circuit in easy way. Okay, yes. So first, read this question carefully. Yes, very nice. So now this is our first example, my dear friend. Okay, first tell me everyone, okay, because I don't want to handle this question, I want to handle this question with your help. First tell me, my dear friend, in any, see the properly, okay, see beta, in any resistance, current is known or not, your first task, or the voltage of any resistance is known or not. Okay, so the first statement, the current of any resistance is known or not. First thing. Second, or beta, the voltage, that means potential difference of any resistance known or not. Okay, please identify this thing first. Very nice, my dear friend. So here beta, please mind it, the this 6 ohm current is known. This 6 ohm current is known. Hopefully this thing is clear. Now my dear friend, if known, directly start your solution. Directly start your solution by Ohm's law. By Ohm's law. Directly start your solution by Ohm's law. This is the thing. Okay, let us assume, my dear friend, this 8 ampere is not given, then definitely we cannot begin the solution of this example just by Ohm's law. Then definitely either we require KCL, KVL or any other method, but definitely not Ohm's law. Hopefully this statement is also clear to all of you. Yes, very nice, very nice, very nice. Now my dear friend, can you tell me how we can handle this example at this moment? Okay, can you tell me, dear, how we can handle this example at this moment? So first I want to remove this thing, okay, because I want to copy this circuit. Okay, yeah, this is okay, no issue. Okay, so now beta, can you tell me how we can handle this thing or this circuit by Ohm's law, just by Ohm's law? So I want to increase the size of this circuit, okay, so that each and everything we can discuss only in this circuit. We don't require any long mathematical analysis or any mathematical job, okay. So please be serious at this moment and try to understand each point, whatever I want to tell you at this moment, okay. So yeah, reflection will be somewhat poor at this moment, but please don't get panic from my face, okay. I think you are comfortable with this screen. Are you comfortable or not? Please tell me fast, dear, please tell me fast, beta. Are you comfortable with the screen or should I take this example? Okay, do one thing. I want to draw this example somewhere here, okay. So 100 volt 6 ohm, okay, I have changed this color but still something is happening, okay, no issue. Yeah, tell me, dear, should I draw or you are comfortable with this? Yeah, very nice, no problem. So I want to show here. Now it is okay, okay. Yes, very nice. Now try to understand first thing. Please, my dear friend, mind it. What is Ohm's law? Ohm's law is nothing but I proportional to V. Ohm's law is nothing but I proportional to V. Job is done. Now, my first question, can you tell me, dear, what will be the voltage or potential difference across this 6 ohm resistance according to this 8 ampere direction? So see beta, 8 ampere current will flow higher to lower potential from this resistance. So can we write plus minus 8 into 6, 48 volts. Please tell me this thing is clear or not. Everyone beta, please, it's my request. I need response at this moment, okay? Without your response, we can't do visuals clearly. Thank you. Now beta, this thing. Now any circuit, whatever circuit we want to handle, we always require one reference point, okay? We always require some reference point. So with respect to this reference point, can you tell me, dear, how much voltage will appear at this node? Is nothing but 0 volt. It's my humble request, if you are not serious, please quit this platform. And if you are serious, listen to me carefully at every moment. I'm somewhat different type faculty, okay? I want to deliver somewhat a good quality of examples and a good quality of content. But for those things, really I need your full concentration, okay? If you are not comfortable with the screen, I will change entire things, okay? But seriously, at this moment, I need your full concentration, okay? Otherwise, this session totally will be waste, okay? So see, but a ground is here, so 0 volt will here. Why? Because no drop in between these 2 points. But here, but a 100 volt drop. So at this node, how much voltage will come? 100 volts, okay? 100 volts. This is the thing. So these 2 things we have done. What we have to calculate? We have to calculate power delivered by this current source I. What is the power delivered by this current source I? Is nothing but the voltage across this current, the voltage across this current source into this I. This is nothing but power, DC power, P is equal to VI. So actually we require, my dear friend, the value of this current I as well as the voltage across this current source. Hopefully these statements are clear again. Now, to calculate this current I, we require this current, that current, and so on. And obviously, to calculate this voltage, again we require current through this resistance. Okay. So what we can do, we can easily identify this current, value of this current or the voltage across this current source by Ohm's law. How we are going to discuss. See here. So with respect to ground, beta 0 volt, 100 volt, and here 8 ampere current is given already. So 8 into 6 is nothing but 48 volts. So 100 minus 48. Can you tell me, everyone, how much voltage will appear at this node? How much voltage will appear at this node? 100 minus 48. How we can calculate this voltage? Please be serious. Let us assume beta some element X is there. Okay. And I want to write somewhere here, this is the VA, this is the VB, and here some voltage is VC something. So we can write VA minus VC, sorry, VA minus this VB is equal to VC. You have to stand somewhere here and try to identify what is the voltage at the upcoming node. So VA minus VB is equal to the polarity whatever you are observing. So plus sign is equal to VC. So VA minus VB is equal to VC. Similarly here beta 100, let us assume this voltage is some VA. This is voltage some VA. Okay. So what will be the potential difference beta? 100 minus this VA is equal to 48. So what will be the VA 100 minus 48? So how much this VA will come? I want to write this VA, okay. So here I want to write some VA, okay. Here I want to write VA beta. So this VA will come 52 volts, I think. Yes, please everyone check it beta. VA will be 52 volts. Yes, everyone, very nice dear, 52 volts. Now can you tell me how much current beta will flow through this resistance, 5 ohm. So see, with respect to ground, how much voltage will appear here is nothing but 40 volts. Is nothing but 40 volts. Done. Now beta, 52 is higher than 40, obviously. Next thing, in between this node and that node, only one resistance is given. And the potential difference known, resistance known, we can apply Ohm's law. So what will be the direction of current first? The direction of current will be downward. Why it will be downward? Because higher and lower. Second thing, by Ohm's law beta, this voltage minus that voltage divided by this resistance is equal to that current. So is nothing but 52 minus 40 is how much? 12. 12 by 5 is 1.6. 12 by 5, 2.4. So this current will come, my dear friend, 2.4 ampere. Please tell me everyone, till now all the points are clear. Yeah, very nice, very nice. Next beta, again I want to ask you a few things. See, 8 ampere here, 2.4 ampere here. So how much current will deliver in the third arm or third branch here? So 8 minus 2.4 KCL, simple KCL. How much current will here? So 8 minus 4, okay. So 8 minus 2.4. Actually, I don't want to do any silly mistakes, so that's why using calculator. So 5.4 ampere, done. Now beta see, this resistance 10 ohm and 18 volts are connected in series. In series, are connected in series. Just give me a few seconds. Yeah. So entire things disturbed. This is 48 volts. This is 2.4 ampere. This is beta 5.4 ampere. So can you tell me how much voltage will develop across this 10 ohm? Across this 10 ohm, everyone, 52 volts. Across this 10 ohm. So beta 5.4 into 10 according to Ohm's law. So here beta higher lower, because current will flow in this direction. So higher lower, positive and negative, 10 and 5.4 is nothing but 54 volts. 54 volts. Okay. Now tell me, till now these points are clear. Okay. Everyone. Yes. Everyone tell me. Everyone. Okay. Next time I will not consider this white color screen. Okay. Done. Very nice. Next point beta. Please be serious at this moment. Again, I want to identify this node voltage. Let us assume some VB. Can you tell me anyone what will be this VB? everyone, see, we are not using any KCL, KVL. We are handling this circuit just by Ohm's law. Just by Ohm's law. Yes. Yes, very nice, very nice, very nice. Now see beta, how we can write potential difference. Try to understand. See, this is the node voltage, so we can write 52. Now, end node voltage minus VB is equal to total difference. So see, positive sign 54 beta, and then minus sign minus 18. Minus 18. So how much this VB? This is 54 minus 18. Yeah, done. So this one and minus 52. I think 16 volt. Yeah, it is correct or not? Dear, please tell me. This voltage will come 16 volts. Okay. Yes, tell me, dear. 16 volts. Very nice. Everyone tell me fast. Okay. Yeah, 16 volts. So now you check it and tell me, sir, you written 5.4 current, it will come 5.6. Okay, thank you. 5.6 ampere. 5.6 ampere. Then entire things will be wrong. So here beta, just give me few seconds. 54 in place of 54, we have to write 56. So here beta, 52. This is correct now. Yeah, 52 minus VB is equal to beta here 56. 56 and minus 18. Job is done. So how much this one? 56 minus 18 and 52 minus answer. Yeah, 14 volts I think. So this is coming beta 14 volts. Please tell me here. Okay, 14 volts. Now everyone tell me it is clear. Very nice. Yeah, 14 volts. So now can you tell me dear, what will be the current through this 6 ohm resistance? See properly. But with respect to ground somewhere here, what will be the voltage at this node? It's really very easy now. Voltage at this node is minus 30 volts, minus 38 volts. Now what will be the voltage difference across this resistance? See properly beta, 14 and this 38 potential difference. This is the higher, this one is lower. So current direction still will be in downward. Now, how much total voltage? 14 plus 38. So 14 plus 38. 52 divided by 6. So how much current will flow here? 8.667 ampere. Now tell me, it is correct? Yes, very nice boss. 8 point something, behtrin. Now next question my dear friend here. This current, entering current is 5.6 ampere. This 8.66 something is downward current. So to balance KCL, actually beta, we require some current in this direction. So the addition of this and that current must be equal to this one. Hopefully you are agree again. It is the basic thing. So 8.66 something minus 5.6 will be 3.06. So here current will be 3.06 ampere. Okay, please check the calculation. Okay, 3.06. Now the direction of current is this one beta. So what will be the voltage developed across this 2 ohm? High to low. So this side positive, this side negative, and 2 into this is total 6.13. So this voltage I am writing somewhere here, 6.13 volts. Hopefully this thing is clear. Now everyone beta, can you tell me the voltage at this node VC? The voltage at this node VC? Yes, very nice. The voltage at the node of VC. Yes. See here, how much this voltage will come VC? See, I want to write here beta, what will be the VC? VC means this VB, and VB is how much coming? 14. So 14 minus this VC is equal to overall potential difference. So this time beta, from VB side, the sign is coming negative. So we can write minus 6.13. Done. And this is the positive, so plus 25. Hopefully this job is clear to everyone. VB minus VC is equal to, my dear friend, minus 6 point something and plus 25. So this is the thing. Now how much this voltage will come? Please give me a few seconds. 25 minus 25 minus 6.13. Yeah, this is a positive one, and my 14 minus answer. So I think this VC is coming minus of 4.87 volts. Please tell me it is correct or not. Very nice, Jaipal. Very nice, beta. So this is the VC minus 4.87. So this is the VC. If my calculation is correct, my dear friend, then we don't have any a problem. Okay. If there is some mistake in the calculation, then this is the next thing. But the most important thing, whatever we have discussed, concept, all the concepts are absolutely correct and fantastic. So at this moment, how much this VC is coming, beta? Minus 4.87. So this VC is coming minus 4.87 is equal to, I want to write here, minus 4.87 volts. Job is done. So now see, beta, here ground, and this is the negative one. This is the negative one. So what will be the direction of current? High to low, upward. And how much current will flow? This voltage divided by 10, because only this is the difference. So this will come, beta, 0.487 ampere. Hopefully this thing is clear. Now, how much entering at this node? This one. How much leaving? 3.08. Then obviously to fulfill this current, beta, we require some current in this direction. We require some current in this direction. And how much current we require? This is 3.08 minus 0.487. And it is coming 2.593 ampere. 2.593 ampere. Okay, so now addition of both current will satisfy this current magnitude 3.08 something. Now my dear friend, I want to again ask you very easy question. What is the voltage across this resistance? Is nothing but minus 4.87. So negative positive 4.87 volts. Okay, now this current source and that resistance both are connected in parallel. So what will be the voltage across current source? My dear friend, same. So here we have same voltage minus plus this one. Now see, my dear friend, again the current source current is flowing from positive to negative. Positive to negative. Positive to negative. Positive to negative means this current source will absorb power. Is correct or not? Yes, please tell me everyone. This current source will, absorb power or not? Vijay and Jaipal, everyone please. This current source will absorb power, yes or no? Yes, my dear friend, because current is flowing from positive to negative. So what will be the power absorbed by this current source? Is very easy. 2.593 into, my dear friend, this voltage 4.87. 4.87. So how much this will come? 2.593 into 4.87. This will come 12.6279 watt absorbing. So what will be the delivering power? Delivering power will be 12.6279 watt is our final answer. Okay. Yes, now tell me, dear. Yeah, very nice, very nice. Now, so we will not consider any white screen after this moment. So I will copy this question meanwhile. And if you have any doubt in the previous example, please tell me everyone. Otherwise, my dear friend, you have to handle this question. Please read the question carefully. Calculate the value of resistance R. Calculate the value of resistance R and show your talent at this moment. We have really discussed a good quality of problem. Use all the concepts. Whatever we have discussed earlier, those concepts you can apply in this circuit also. You have to calculate the value beta resistance R, this one. Okay. So meanwhile, I want to redraw this circuit somewhere here. Okay. So you start your job. Just try to understand beta first thing, whether the resistance current directly is given or not, or the voltage across resistance is given or not. Okay. is given or not. So think over it. Okay. Meanwhile, I want to copy. So 60, 40, 20. Okay, just give me a few seconds. Now, you handle. Okay, so here we have to identify the value of resistance R. Just give me a few seconds. So here we have some voltage, that is 60 volts, and some current, 15 ampere, and then one more resistance. How much? 5 ohm. And then 10 ohm, this one, minus plus 20 volts, 10 ohm, okay. And then another R1 somewhere here is also present, then minus plus, and connected here, minus plus 40 volts, and this current is given 5 ampere in downward direction, okay. Then now we have some battery. We have some battery in this fashion, okay. This battery is 40 volts plus minus, and then we have some resistance here, and again some battery in this fashion, and connected here, minus plus 18 volts, and this is 10 ohm, and then here we have some 10 ohm resistance and our R, okay. So this is R and this one is 10 ohm. Let me check this example again. So minus 20, 10, minus 45, R1, 5 ohm, 15, 60, okay, 40 and 10, minus plus 18, 10 R. Yes, so this example is done. Okay, very nice. Now dear, tell me what will be the value of R? What will be the value of R? Yes, everyone please. What will be the value of R in this example? Read this example carefully again. Okay, here we have to calculate the value of R. Here we have to calculate the value of R. Yes. See, first listen to me carefully everyone and tell me dear, how we can calculate this value of R either in ESE objective exam or GATE. Okay, or in GATE. See my dear friend, first identify, okay, whether any resistance, current or voltage are directly given or not. If directly given, then we can easily handle any circuit just by applying Ohm's law. You are getting my point? Yeah, diagram is little complicated. No, see the diagram is really Vijay and everyone not too much complicated. Okay, see here we have to play some magic things. That's why I have taken such type of examples for the better understanding of Ohm's law, and I want to show you the beauty of Ohm's law. Okay, the beauty of Ohm's law, how we can handle such type circuit within few equations, hardly one or two, and sometimes we don't require any equations mathematically. Okay, now here see, first thing beta, we can consider some ground point here. Job is done. Ground point here. Okay, now see how much current beta is flowing here. 15. How much current flowing here? 5. But resistance, currents and voltage are not given. Okay, this is the question mark. If the resistance, current or voltage are given, then we can easily handle by Ohm's law. Okay, so pause here, and now what we have to identify beta? We have to identify this R, and this R is nothing but the voltage across this R and the current through this R. Okay, ratio V by I. So basically we have to identify the beta voltage across this and current through this, and if the both things are known, we can easily identify the value of R. Yes, very nice. Now see, see, observe carefully. Can we calculate directly beta current through any resistance? Current through any resistance. Okay, see, here no currents are given, only currents are given in this section. You are an engineer, my dear friend. You have good quality of mind. Okay, you can mold your IQ level instantaneously according to the problem. Okay, please never say the problem circuit or anything somewhat complicated. My dear friend, the life is somewhat complex. Okay, and the complexity of life is really not comparable in or with respect to our technical field or non-technical field or anything. So hopefully you are getting my points. Okay, this is the beginning, my dear friends. So try to understand each and everything whatever we want to discuss related to application of Ohm's law. And I assure you, after the discussion of this this question, you will realize that, oh my God, that was a really easy question. Okay, so see how we can handle. First, beta, here current given, here current given. Now can we identify this third arm current? Yes sir, very easy. How, boss? This 15 ampere leaving, my dear friend, this 5 ampere entering here, then how much current here we require to satisfy this KCL? Sir, we are studying that type of thing from our 10th standard. Now we are comfortable. 5 ampere here, here we require 15. So how much current will flow here? Sir, obviously 10 ampere. Job is done. Now once 10 ampere current through any resistor node, yes, now we can apply directly Ohm's law. Now we can apply directly Ohm's law. What will be the thing here, beta? The current direction is downward. The voltage developed across this resistance is 10 into 10 is nothing but 100 volts. Is nothing but 100 volts. Job is again done. So now see here, can we say, beta, with respect to ground, here voltage at this node is 60 volts because no drop. And here voltage, my dear friend, is minus 40 volts. Hopefully this thing is clear. And now, beta, no drop. So at this node, voltage is minus 40 volts. Tell me, balakain, everyone, dear student, till now all the points are clear or not? Yes, everyone. Till now all the points are clear or not? Everyone, boss. Yes, boss. All the points are clear. See, next thing, my dear friend. How much current, beta, here? 10. Here voltage 20, here voltage 100. Can you tell me, my dear friend, the voltage at this node? I want to write some VA. Please, start your job. What will be the, sir, R1 के across current भी फिर 0 होगा? Okay, I'm not sure whether current through R1 will be 0 or not. Okay, we can identify, my dear friend. We can identify. Okay. So now, can you tell me, dear, this VA voltage? Why we require? Because we want to calculate these currents, beta. And to calculate these currents, we require that current also. So that's why we require this VA. So can you tell me this VA? So see how we can calculate. VA, my dear friend, VA minus this 0. Okay, so 0 is equal to how much, beta? This is positive 100. From this side, see the polarity, and then minus 20. So how much this VA? VA simply will be 80 volts. Hopefully this thing is clear. Yes, I'm not enjoying this session, yaar. You have to show, beta. Okay, your presence. Okay, you can ask your doubt. Are you enjoying or not? You have to tell, yaar. Only then we can discuss good quality of problems. Okay. So how much, beta? VA minus 0 is equal to positive 100 minus 20. So this VA will come 80 volts. Job is done. So here we can write, my dear friend, this VA is 80 volts. Okay, job is done. How much here, beta? 60 volt. No issue. So 80 minus 60, how much? 20. And 20 by 5 is our current. So see, 80 is higher, 60 is lower. According to Ohm's law, potential difference across this resistance is nothing but, in this fashion, beta, 20 volts. 80 minus 60. And 20 by 5, this current is nothing but 4 ampere. Hopefully this thing is clear. And 4 and 15 both are entering. So here current will be 19 ampere. Please tell me till now it is clear. Yeah, please tell me till now it is clear or not, dear. Yes, till now it is clear or not? Okay, so this is the 19. Similarly here, beta, we can till now we cannot identify this R1. But see here, how much current, beta? 4 ampere. How much current? 10 ampere. 4 leaving, 10 leaving. So how much current here we require is obviously 15 ampere. is obviously 15 ampere. So 14 leaving and this 5 leaving. So here beta the current is 14 plus 5 is nothing but 19 ampere. Hopefully this thing is clear. So 19 ampere here, 19 ampere here. Job is done. Okay, job is done. Very nice. Now see properly, my dear friend. With respect to ground beta, how much voltage will appear here? How much voltage will appear here? See 60 and 40. So this is nothing but 100 volts. Same polarity, plus minus 60 plus minus 40. So this is 100 volt. Okay, this is 100 volt. Very nice. Now how much voltage at this node beta? Is nothing but minus 40 volt. Already we have discussed. So can you tell me current through this resistance? Current through this resistance is very easy. See, I want to say beta, please mind it, I want to say the current I will be in this fashion. Okay, either it is correct or not, we can identify by potential difference. So first tell me what will be the voltage at this node VC. VC. So see, we can write beta VC, this one, VC minus this 40. So minus 40, okay, is equal to how much? Minus 18. Job is done. VC minus 14 is equals to beta minus 18. Done. So how much this total voltage will be there? Minus 18 and so minus plus and again minus, so 14. So 58. So VC will be finally 58 volts. Okay. So this VC will come, I think, 58 volts. Please tell me whether it is correct or not. Yeah. Everyone, please tell me beta whether it is correct or not. 58 volts. So how much this current beta? 100 minus 58 divided by 10. 100 minus 58 divided by 10. So 100 minus 58 is 42, I think. So 42 by 10 is nothing but beta 4.2 ampere. Okay. So check it whether it is correct or not. Yeah. So 4.2 ampere is done. Very nice. Now see here beta. 19 ampere entering and 4.2 ampere leaving. So how much current will enter here? So how much current will enter here? See properly. How much current will enter here? That is nothing but beta 19 minus this. Okay. So 19 minus this is 14.8 ampere. This is also clear. 14.8 ampere. Very nice. Now see how much voltage will develop across this R. Current direction is this one, positive and negative, high to low. 14.8 into 10 is nothing but 148 volts. Is nothing but 148 volts. Now my dear friend, can you tell me the voltage at this node VD? The voltage at this node VD, because actually we require this voltage. Okay. So see properly here beta. We can write VD minus 100 is equal to this potential difference. So see properly. We can write VD minus 100 is equal to beta from your side minus 148. Okay. Hopefully it is clear. VD minus 100 is equal to minus 148. So how much this voltage will be? So VD is nothing but 100 positive. So minus 48 volts. So VD is nothing but minus 48. Very nice beta. Minus 48 volts. So this is minus 48 volts. Job is done. Now see beta, which one is higher, minus 48 or minus 40? So obviously minus 40. See, try to understand which one is higher beta, minus 40 or minus 48. See properly. Let us assume this is the current I in this direction. So what we can write at this point? See properly. I is equal to, from this way beta, so minus this 48 and minus plus beta 40 divided by this R. Job is done. Okay. Now beta, this current will be negative. So finally this current will flow in this fashion. Okay. Actual direction. So what will be the I beta? I will be 8 by R, 48 and 4. So I will be 8 by R in this direction, opposite direction. what will be the value of R? R is nothing but beta this 8 by I, and I is this one 14.8. 14.8. Okay. Hopefully this thing is clear. So now try to understand all the points. So 8 by 14.8. Yeah, 0.54 I think. So if my calculations are correct beta, then definitely your answer should be like this. Yeah, very nice boss, very nice. Okay, so by this approach we can handle beta any example, and see there is no complexity. Just we have to apply Ohm's law, Ohm's law, Ohm's law, Ohm's law everywhere, and by handling Ohm's law we can easily like handle our questions. Okay, yes, please tell me all the points are clear or not. Okay boss, just keep one point in your mind. Okay, recheck the calculation. Okay, everyone, dear, recheck the calculation so that you can understand each point related to the circuit. Okay, now we are going to handle our next example. Okay, next example is again very easy. Okay, not too much difficult. See, we are discussing our examples in such a way so that, my dear friend, we can understand a lot of things related to circuit theory. Okay, so read this example carefully and try to understand the depth concept of the question. Take a deep breath and then reply answer of this question. Okay, I want to read this question. A circuit as shown in figure has two ideal independent DC voltage sources, V1 and V2, and the voltage of both sources are non-zero positive values. Means beta V1 and V2 are not equal to 0 and they are positive values. Then which of the following statements will be true? Okay, V1 is greater than V2. Okay, V1 is greater than V2, comma, V1 will absorb 10 watt power, whereas V2 will deliver 0 watt power. When this condition, okay, if the condition is this, V1 is greater than V2, then this statement will be correct or not. Similarly, beta, when V1 is less than V2, then V1 absorb 50 watt, V2 will deliver 50 watt. V1 is greater than V2, then V1 absorb 100 watt power, whereas V2 will deliver less than 100. Similarly, beta, V1 is greater than V2, V1 absorb 30 watt power, whereas V2 will deliver 20 watt power. In some situations, in some conditions, so such type of example really require good quality of knowledge related to your circuit theory. Good quality of knowledge related to circuit theory. Okay. Okay. Thank you, Hassan. Now try to understand this example and read the example carefully. We are not in hurry. You can take near about 1 to 2 minutes, dear. Okay. So, okay, do one thing. We are not in hurry. So try to understand this example and take around 2 to 3 minutes. Okay. 2 to 3 minutes. Then we will discuss after 2 to 3 minutes. Okay. So you have a sufficient time. Now think over it. Now think over it. Okay, I will not speak anything. You just try to understand the question. Okay, any answer dear? Almost 3 minutes over. Yes, any answer dear? Till now I didn't receive any answer. Okay? Yes. Read the question carefully again. See my dear friend. Think properly about the question. Okay, what is the problem? How we can handle such type of problems in our examination? Okay, yeah. So D, Vijay, maybe more than one answer can be correct. Okay, so you have to think properly about every option. See, try to understand. First, I want to tell you first thing. See, ideal independent DC voltage sources. As DC sir told you, what is the definition of ideal DC voltage sources? V1 and V2. And voltage of both sources are non-zero positive values. It means, my dear friend, whatever this V1 and V2, guaranteed those values will be positive. So you don't have authority to change the polarity. Okay, you don't have authority to change the polarity because already mentioned both voltages are positive. Hopefully this thing is clear. Both voltages are positive. Next thing, my dear friend, according to problem, then which of the following statements will be true? See properly. This V1 is not equal to 0 and positive. V2 is not equal to 0 and positive. And here, whatever current will flow somewhere here, beta, either in this direction or in that direction, current through both voltage sources will be equal or not. Please tell me. Will be equal or not? Everyone, I need answer beta from your side. Will be equal or not? Whatever current will flow here, okay, through the voltage sources will be equal or not? Okay, yes, tell me. So, yes, sir, but ये question tackle नहीं हो पाया. No issue, Vijay. We will discuss, okay, so that we can understand lot of concepts related to circuit. So now this current and that current will be same. Very nice, equal. It means, my dear friend, whatever power will here cannot be 0 because this I will be there, this I will be there, and whatever power will be here, that cannot be 0. In other words, this power can be 0, but both. So see, either both power P1, P2 will not be 0 or will be equal to 0. It is impossible to say that this power is not equal to 0 whereas this power is equal to 0. You are getting my point? See, I is not equal to 0, then that means both power will not be 0. And if I 0, then both power will be 0. This is the simple statement. So see here, what is the first statement? If V1 is greater than V2, then V1 will absorb 10 watt and V2 will deliver 0 watt. It is impossible because for 10 watt power of V1, we require I is not equal to 0. Hopefully you are getting. I is not equal to 0 and V2 is also not 0. So I not 0, V2 not 0. It means V2 will also deliver or absorb some power, but definitely at this condition, this power cannot be 0. Hopefully this statement is clear to all of you. Very nice, very nice. So option A cannot be correct, my dear friend. Why? We have explained. So now, my dear friend, here we can write first thing, the power of V1 and V2 will be 0 only when I want to write some I, only when I will be 0. Only when I is equal to 0. Hopefully this thing is clear. Done? Very nice. Now I want to ask you next question, beta. Next statement. V1 is less than V2. Okay? V1 is less than V2. So I want to remove all the things so that we can discuss here. Okay? Yes. Now, first statement is done. So it is related to option A. Now what about option B? V1 is less than V2. That means this V1 is less than V2. Job is done. So here we can write, my dear friend, related to option B, V1 is less than V2. Done. Now what is the information? when V1 less than V2, V1 absorb 50 watt power and V2 will deliver 50 watt power. See properly. What is the thing? Regarding V1 and V2, nothing is given. Nothing is given. Okay, nothing is given. Like V1 magnitude and V2 magnitude either equal or not equal. I need your full concentration, my dear friend. Otherwise, okay, so just understand at this moment when you are learning something from my side. Okay, at this moment or in this situation, you have to apply your full concentration. Okay, otherwise the concept you cannot understand. See, beta, related magnitude of V1 and V2, nothing is given. But now this information is given, V1 less than V2. That means for time being, I want to say this is the 10 volt beta and this is 20 volt roughly, just at this condition, V1 less than V2. Now what is the thing? Here, my dear friend, this thing is saying this power beta will be some value, obviously not 0. And this power will be some value, obviously not 0. And current whatever will flow here beta will always be same. Doesn't matter these values are equal or not. Doesn't matter. The current whatever flow through this batteries will always be same. Now my question is this, if this particular voltage is lower than this, and then he is writing, or that person is writing, even I have designed this question, so I am writing, my dear friend, here V1 will absorb 50 watt and V2 will deliver 50 watt. Is it possible? Both powers are equal, deliver and absorbing, whereas V1 is not equal to V2, but current are equal. So can we write beta here, P1 is equal to V1 some I and P2 is equal to V2 and I, both I are equal, but V1 is less than V2, so obviously P1 cannot be equal to P2. You are getting my point beta? P1 is not equals to P2. Hopefully this thing is clear. And if this thing is clear, then obviously option B will be correct or incorrect. Please tell me. Will be correct? Yeah, very nice beta. So B cannot be correct. B cannot be correct. B, when it can be correct? B or Bombay option can be correct only when that person or me, if I will mention V1 equal to V2, then in this situation there will be some possibility of this option B. Okay, hopefully this thing is clear. Very nice. Okay, now what about C option? If V1 greater than V2, then V1 will absorb 100 watt, whereas beta this V2 will deliver 100 watt. This is the another thing. I want to repeat. V1 is greater than V2, V1 absorb 100 watt and V2 will deliver less than 100 watt, less than 100 watt. See, V1 greater than V2, so I am writing here beta, this C statement here, okay. So C statement, V1 greater than V2, V1 greater than V2, this is the condition. Now, give me a few seconds. V1 greater than V2, V1 absorb 100 watt and V2 will deliver less than 100. So V1 absorb 100 watt, and V2 will deliver less than 100 watt. Now maybe that option C can be correct, but we require some time. We require some time to think over it, whether we are doing correct or not beta. Okay, so for the best conclusion, again I want to remove those things and we will understand what is the thing. Here beta V1 is greater than V2. So at this moment, let us assume roughly, I want to say this is 10 volt. Okay, I want to assume this is 10 volts and that one is roughly 5 volts. Okay, done. Now what is the thing beta? Current direction will be upward or downward, we have to think. Here how much voltage here beta? How much current here? 2 ampere, and that current is an independent quantity. This job is done. If this voltage higher and that voltage lower, if this voltage higher, that voltage lower beta, then definitely resistance across the voltage across this resistance will be in this fashion, because are in parallel, and this is higher, this is lower, so voltage across this will be something like this. Now beta current will flow in downward direction and I want to give some name to this current is I1. Done. Now see, this 2 ampere is entering, beta. This 2 ampere is entering, and somewhere here this current will flow in this fashion. To satisfy this thing is one job. Possibilities, not final conclusion. See, this current direction is fixed. This current direction, suppose I want to say some ICS. This current direction fixed. This current direction fixed. Only that current direction is still clear whether it is correct or not. One thing is given, this voltage is higher than that one. So here we can write 0.1, then 0.01, 0.2, 0.1, 1, 0.8, 10, 5, 100, 200, 180, anything. So many options are there. So here this direction of current is still not fixed. This direction of current is still not fixed. Which direction is not fixed? I. Why? Because my dear friend, let us assume this is 10 volt, this is 5 volt, roughly. So how much voltage will appear at this node? How much voltage will appear at this node? But V1, so here we can write some, I want to write here, this is VA, see properly. So VA minus, here I want to take ground, so ground, 0 is equal to, my dear friend, positive 10. Okay, positive 10 and then minus 5. So minus 5, so VA will be simply 5 volts. Hopefully this thing is also clear. Very nice beta, very nice. सर जी अगर करंट सोर्स के साथ पैरेलल में रेजिस्टेंस लगता है तो उसका रेजिस्टेंस को नेग्लेक्ट कर सकते हैं कि नहीं? नो बेटा, नेवर डू दिस थिंग. Okay, when we can neglect, that circuit situation will decide, but at this moment we can't neglect, okay, because some current will flow through this resistance. Now see beta, how much this voltage is coming? 5 volt. So see, if this voltage is coming 5 volt, my dear friend, so this current will be 5 by 10 is nothing but 0.5 ampere. And how much current beta? This is 2 ampere. So 2 and 0.5. So in this wire, current will flow in this fashion beta, 1.5 ampere to satisfy KCL. This thing is clear. Now let us assume beta this voltage is somewhat higher, 100, and this is 10 only. This 100 and 10. Then how much voltage will come here? 90, and 90 by 10 is 9 ampere. 90 by 10 is 9 ampere. Now this current is somewhat higher in comparison to this. In that situation, current will flow in upward direction to satisfy this current. So this current basically will depends upon the exact magnitude of V1 and V2. And the exact magnitude of V1 and V2 will finalize whether your current direction will be upward or downward. Okay, this is the first thing, not related to our question, but I want to tell you. Okay, yes, please tell me till now all the points are clear. Okay, chaliye, everyone please tell me till now all the points are clear or not. Now I want to follow this option. Okay, so what is this option? V1 is greater than V2, then V1 absorb 100 watt and V2 will deliver 100 watt. Sorry, V2 will deliver less than 100 watt. Now this statement I want to follow in this circuit. Okay, so this is the analysis about the circuit. Now I want to consider that thing. So see properly, I want to remove all those things and just we have to mention, or I want to mention beta, this is some plus 10 volts and this is some 5 volt. Okay, done. Now in this situation he is saying V1 absorb 100 watt. Absorb means, my dear friend, in this fashion. Absorb means current must flow in this fashion. So this is the direction of current I according to this information. And V2 will deliver. Obviously, if the current is flowing in this fashion, then this one will deliver. Hopefully this thing clear. And less than 100, that person is saying. So obviously, dear, obviously, in this case, we have to maintain one concept in this way. 10 into this I will be greater than 5 into I. So property is satisfying. And in this situation beta, these batteries magnitude will compensate itself, okay, to manage this condition. So this is one possibility at which V1 will deliver more power in comparison to, or V1 will absorb more power in comparison to V2. So what will happen in this situation? V1 will absorb this resistance, my dear friend, will absorb, and this is higher, so voltage will be in this fashion, and current is flowing in upward direction, negative to positive. So when this V1 will absorb power, resistance will always absorb power, so both element will absorb power, and this V2 and current source will satisfy Telegon's theorem by delivering powers. So according to energy conservation law or Telegon's theorem, this statement C is going to satisfy. Please tell me it is clear or not. This statement C is going to satisfy. Okay. See, my dear friend, as a teacher I want to suggest you, circuit theory is not a joke at all. Okay. For the better understanding of this subject, we have to spend, like honestly I am speaking, we have to spend particular time with this subject. Okay. And we know that this circuit theory is kind of heart of electrical core as well as electronics core. Okay. We can't take even single step without the knowledge of circuit theory or good knowledge of circuit theory, either in instrumentation branch or electronics and communication as well as electrical engineering. Okay. So it's my humble request, please mold yourself for the better or best content. Okay. See, whenever we are discussing some problem, you have to give your full attention. Okay. Otherwise, you know very well, just by handling current or voltage questions, okay, sometimes we will not be capable to handle good quality of question in our examination, especially in ESE subjective and gate exam, okay, and many other exam, for example ISRO, BARC interview and so on. Okay. Yeah, so very nice dear, very nice. Okay. Yeah, so this is the thing. Now my dear friend, on this base, this option C is correct. Now can you tell me what about option D? Option D is saying V1 is greater than V2, V1 absorb at a 30 watt power and V2 will deliver 20 watt power. What is this thing? This is the similar to option C now. This is similar to option C, my dear friend. V1 greater than V2, done. V1 absorb 30, V2 will deliver 20, done. Okay, doesn't matter. See, option C and D are absolutely same because nothing is given about the V1 and V2 magnitude is, just they wrote V1 higher than V2. Okay, in that case you have a lot of answers, okay, according to the numerical values. So this option D is similar to option C. So my dear friend, option C and D both are absolutely correct. Both are absolutely correct. Please tell me everyone, you have clear all the concept or do you have any doubt? Yes, boss. Yeah, Umesh Joshi, this video for ESE 21 or GATE. No, this video for ESE 21, but definitely at first I want to improve your concept, then we will discuss ESE objective question. Okay. First, with the help of like 6 to 7 examples, we want to improve our basics. Then we will discuss, because after handling such type of questions, I assure you, you will be easily handle ESE prelims question as well as ESE subjective questions. Okay, and in this year we don't have a big difference in between prelims and mains. So it's my suggestion that you have to prepare yourself for mains as well as prelims. Okay, both. Okay, because hardly I think 2 months gap is there in between prelims and mains. Okay, yeah. So hopefully this thing is clear. Very nice. Now, my dear friend, I want to give you very easy example related to ESE or GATE. Okay, so yeah, something is. Yeah, so just read this question carefully and tell me what will be the correct answer. Okay, just read this question carefully and please don't follow any KCL, KVL after that much of discussion. Please don't follow any KCL, KVL. Okay, if you don't require. If you required, you can follow. But think properly, either you required or not. Either you required or not. Yeah, very nice, Patel and everyone. Yeah, in the given something circuit, what will be the value of R? What I told you first, Okay, sir, I remember your statement. Whenever we have some known current of resistance or known voltage of resistance, then we are not supposed to start the solution of our problem by KCL or KVL. It will be better if we want to start our problem by Ohm's law. Okay, this is the just way. Okay, so yes sir, now we are applying your concept or your strategy, whatever you have told me. Okay, see sir, here 8 ampere of this resistance is given, but we cannot identify the voltage across this resistance easily because obviously this resistance is known. Then sir, what we can do? Okay, see another part of this circuit. Here my dear friend, 8 ampere current is flowing. Here my dear friend, 8 ampere current is flowing. Okay, here how much current is flowing? 8 ampere, and equal resistance are there, so obviously 4 ampere and 4 ampere, and if the resistance are unequal, then we can apply my dear friend current division rule. Okay, so till now this statement question is easy. These resistance are equal, so that's why current equally divide 4 and 4. Now by Ohm's law, my dear friend, here we can consider ground. By Ohm's law, 10 into 4 beta, how much voltage? 40 volts. And we know that in parallel voltage will be equal. So the voltage across this resistance will also be 40. So with respect to ground, how much voltage will appear at this node is nothing but 40. And here beta is nothing but 100 volts. Job is done. Now we want to identify this resistance value. Can you tell me what will be the potential difference across this resistance? Yes, everyone. Please tell me fast beta. Yeah, very nice. So how much this one? Voltage difference, 100 minus 40 is nothing but plus minus 60 volts, plus minus 60 volts. So what will be the value of R according to Ohm's law? 60 divided by current. So V by R and 60 by this. So 8 48 8 56 7.5 ohm is our final answer. See, we didn't apply any KCL or KVL. Directly we have handled this question just by Ohm's law. Just by Ohm's law. Hopefully this thing is clear. Okay? Yeah, very nice. So my dear friend, here we are going to stop our session, and if you have any query related to your network theory, okay, you can WhatsApp me on my number 9891706459, and you can join my Telegram channel Ravi@IISC. Okay? Yes, so really you have enjoyed this session. Okay, yeah, please tell me. Yeah, Vijay, you really enjoyed this session. I can understand. I can read your chat. Okay, and you have really good knowledge of circuit theory. That's why you are listening to me continuously. Okay, around 2 hours. Okay, so thank you, dear. We will meet tomorrow at the same timing with ESE example and rest concept related to Ohm's law. So in the tomorrow class, in beginning, we will discuss around 3 to 4 examples. Okay, good quality of examples designed by me, and then we will take ESE prelims example and 1 to 2 examples related to ESE mains. Okay, yeah, thank you, dear. Okay, if you have any query, please ask. Okay, thank you, dear.